Okay, this is problem number one, homework number six, which is to be discussed or to be shown to the GA on March 7th. Now, this is a problem that once you see it, you should realize that it needs to be done with shell elements. That's my expectation. Use the most appropriate element because it's a thin, essentially thin structure. Thinness had nothing to do with it, but it is, I'm expecting this to be done with shell elements, okay? The edges, this edge of the circles on the top and the bottom are clamped, and there is a side pressure on this vertical face of 20 psi. Now, it is a problem from previous midterms, so or final exam perhaps, and you should be familiar with it. And also, you're expected to use as many planes of symmetry as possible. There's only one plane of symmetry, and you got it like this. Okay, so you can do only half of the model, create only half of the model, or create the entire model and then cut it. And that's exactly what I'm going to do. I'm going to make the whole model and then cut it. Okay. So let's see. Probably the the fastest way is to create this uh, cross section as a wireframe or as a sketch, and then extrude it in the appropriate direction. So let me go ahead and do that. We start with a part file, and because this is going to involve surfaces, I'm going to go to generative shape design or wireframe and surface design. So on that vertical plane, I will sketch the thing that looks like that uh, cross section, something like this, and I have to put dimensions here to make sure that it is the right size. Let me see now, these are each 8 inches long, so this is 8 inches. Okay, and this is 8. Okay, and that the vertical plate has a thickness of 5. This is 5. Okay, exit. And now I'm going to extrude it in both directions, although we will cut it later on. So mirror extend or mirror extend, and in each direction that will be, you know what, it looks like I have forgotten to give you that side dimension. So this length, I forgot to give you what, based on the drawing, maybe 5 inches, so 2.5 in each direction. Okay, that probably looks like. And now on that top face, I will sketch a circle and center it, because the problem says it's centered completely. So for example, I can say, well, one way is because I know that this way it's exactly halfway, so this way I'll make it 4. Instead of using constraint using the dialog box, I can just put a dimension here, and this is going to be 4 inches. Okay, same thing on this side. Uh, yeah, the thing is that this, I was intending to draw it on that, but let me cheat here. Okay, so let me actually do the following. So what about, I mean, there's a zillion ways of doing these problems. Let me do an extrude this and long enough. Oops, the other direction actually. Uh, do it like that, long enough. Okay, good. And now cut this. Okay, so split that face with this, and let me see now which side is going to remove. Oh yeah, okay. So let's say let's see how it looks like. Yep. Now I can hide this. The problem is that just make sure that when you mesh the stuff, you don't mesh that cylinder. This is a crazy way of doing it, but why not? I want to do it this way. So on that face, I will sketch. That's a ridiculous way of doing it. So let me see now. Let me dimension from here to there, 4 inches. Okay, exit. Yeah, and now I do split that face with, oh, this radius, I forgot to specify what it is. I could have done exactly the same thing on the other side. The only thing is that this sketch, I forgot to say what this radius was. I think these radii, both of them are 1 inches, so I didn't do the other one either. So this is 1 inches. Oh, wait a minute, 1 inch. What did I put here? 1 inch, that's what I want. Okay, exit. And also let me go to the other sketch, this sketch actually, radius 1. Exit. Okay, good. Now we're going to cut this, cut that entire thing with one of these vertical planes, and it doesn't matter which side we pick. Anything that we don't like, we don't want, we can hide. So I'm going to hide these sketches. I'm going to hide this. Good. So let's put some material properties on it. We're going to use steel properties on that part. Say OK. Now we're going to go to, let me save this thing. File, save management, save as, that folder, homework 6, problem 1. Okay, now we're going to go to analysis and simulation, generative structure analysis. I will do the triangular mesh, so I know nothing fancy is needed. Unless you're told otherwise, you do the same thing, please. So I'm going to mesh this with a dimension maybe 0.2. This is parabolic, by the way. Say okay, and notice that that other surface is still in the back. I'm not meshing this, okay, because that was only used to cut this, okay. So if you want to look at the mesh, that's probably very tiny. Yeah, that's fine. That's fine. Deactivate this. Now, give it a thickness. The way I've done it, I don't have to join. The entire thing has a thickness of 0.02, but the vertical plane, this plane has a thickness of 0.01. So I go to properties, put the cursor there, right click, local 2D property. On this, I do a 0.01. Remember, there are other ways of doing it. You can create these surfaces without, I don't know, if you extract it, don't join them, or you can create connection between them. There was one, the chapter that, oh, I think it was lab 5 where I studied meshes, or lab 6. Can't remember, lab 6, I think. Yeah, lab 6. I did create connection between these faces, etc. So you don't have to do it here. Now, let's see now. These edges, this edge is clamped, and so is that edge. Okay, very good. And these are symmetry planes, symmetry edges. So let's see now. These edges, that guy, and this guy, and the vertical one, and this horizontal one, and this one, they all lie in the symmetry plane XZ, so there is no displacement in Y, and rotations are exactly the opposite. And we have a pressure of how many psi? 20 psi. So we have a pressure, yeah, on that face, 20 psi, and change the direction as you see fit. Of course, in this problem, this is fairly uh, symmetric. It really doesn't matter. If you don't like this, turn it the other way around. Okay, I'll just leave it the way it is. Okay, so this is going to push that way. Okay, okay, so that's good. So file, save management. Oops, file, save management, analysis, save as. In that same folder, homework 6, problem 1. Okay, and then run it. Hopefully, we didn't forget anything. I don't think we have. That's pretty much it. So look at the deformation. That makes sense. Anything that you don't like, you can hide. Okay, it's blocking your view. That's the way it should be, right? Now, if you want to see numbers, this may be big numbers here for 23 inches. So that's because of these thicknesses are so small, unrealistic, like aluminum foil. So let me go and actually change this. Let me go and change. Please don't change these on the test. But here I just want to show you that you put garbage in, you get garbage out. So that's okay. And this one is going to be, oh, where's the other one? This one? Yeah, point 0.1. So the point 0.1 means 2 millimeter thickness compared to the other dimension. Let's run it again. Because remember, these thickness deflection has a t cube in it. So it's going to be dramatic decrease in the deflection. 21 inches probably becomes 0.02, something like that. Where is this? I think 1,000 times. Yeah, 0.02. There we are. We already discussed this thing when we did the activities too. So this is 1 meter stress. Yeah, that makes sense. This is almost 20,000 psi. Assuming that we trust these numbers, 20,000 psi. Of course, you have to be careful because the, this is good looking garbage probably. Okay, so because you have to know what the yield strength is. Yield strength of structural steel is about 30,000 psi, but then things may be unrealistic the way it is because usually these have fillets and things like that. So anyway, that's homework 1. Good luck.